Okay, in this video, all I've got basically is just a little recap of things you've been working on the last week and a half or so. You want your radical sheet. And just, I want to recap. I might give you a packet like this to work on tomorrow. Make sure you save this so you got your notes. So when you have to simplify a radical, first off, you break the radical up. It's a 4, so you got 64. You've got x to the third, and you've got y to the sixth. Okay, now I want to look at the list of 4s, okay, and see if 64 is here. It's not. Okay, by the way, right here, what you're going to do is drop your radical. Okay, keep that. You'll bring some of this stuff will go outside, but there'll be some left inside, I think. Okay, so 64, I'd start at 16. So 64 is not here. We divide into it and we write it as 2 different fourth roots. So I'd start dividing 64 by 16. And I got 4. So I cross out the fourth root of 16 and I got 2. So I pull 2 goes outside and the 4 stays inside the radical. Okay, now remember, when we have variables and exponents, what we do is line this up so it's x times x times x. And then we put the radical over 4 of them at a time. But I can't get 4. There's not 4. So I just put a radical over it. And that'll be 3 x's, x to the third in the radical. Now let's talk y to the sixth, okay? That'd be y times y times y times y times y times y. 4 of them, so put the radical over 4 of them at a time. And every time we do it, we are able to get 4, a y comes to the top. And then these are left over. So I have y to the top, so I put y to the outside. And then I have 2 y's left inside, so that's y to the second. There we are. Okay, my next problem, I make a cubed root. And I got 2 cubed roots. And the first one I put 54, then I make a cubed root of y with its power of 10. So let's talk 54. We'd be on this list now. Switch gears. 54 is not here, so we have to divide into it. So we'd start at 27. So 54 divided by 27. Okay, that works. So that's 27 and 2. So I always get rid of this because that actually equals a number, 3. So a 3 is brought to the outside, a 2 is brought to the inside. Now, 10 y's, I know that's kind of annoying when you have to do that, but it's doable. 6, 7, 8, 9, 10. So we're going to do 3 at a time. There's a 3, put a y up. There's a 3, put a y up. There's a 3, put a y up. And then this stays in a radical. So I have 3 y's I was able to bring up. So y to the third comes outside, and a y then is on the inside. Okay, now this is going to end up being the same thing here. When you have multiplication, you need just one radical. Okay, by the way, it's a 2 if you don't have it. Okay, if you don't see a number outside there, it's a 2. So you just have an extra step before you go over here. You make one radical. You don't have anything outside. Those 2's I just put there so I know what list to look at. And then I multiply. I take 8 times 40. It's 320. And then for the y's, I add the powers. 5 plus 2 is 7. Then I do the exact same thing I'm doing up here. Okay, I make a new radical, and some of this will come out, some of it will stay in. Okay, 320. Okay. So I would have to start here. I'd be on this list. Kind of annoying that I have to start all the way down there, but I do. Okay. Remember, you don't see it. If you don't see it there, you have to divide by a number that you do see. Decimal, 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 boring. Okay. Yeah, I don't like doing this when you have to go on forever. Decimal, decimal. Booyah, we got 64 and 5, okay? So the 64 turns into an 8, so that means we can bring an 8 to the outside and a 5 inside. Leave your space for some letters, though. Y to the 7th, that would be y times y times y times y times y times y times y. So 2 at a time, y comes up. A full factor of y comes up. Another full factor of y, then that stays in. So I have y to the 3rd outside and a y inside. Okay, next one, multiplying. Again, same thing that you're doing here. You need just one radical to start with. Before you go over here, you need just one radical. Now, you have something outside. You have a 2, okay? So I place a 2. That's not that big of a deal, okay? And then I take 2 times 4, that's 8. X to the 1st, x second, so I add those, it's x to the 3rd. Then y, 2 plus 5, 7. Now we can come over here, okay? Now, when you make your radical 3, remember that that 2's outside of there, okay? Space it out, but it's outside, okay? All right, so I've got radical cubed root of 8, the cubed root of x to the 3rd, and the cubed root of y to the 7th. Okay, the cubed root of 8. That's here, so it's 2. I put 2, and that goes outside, okay? So I won't have a big number inside. Now, x to the 3rd be x times x times x. Put a radical over 3, and you got x. So that x comes outside, and you're not going to have any x's inside because you didn't have any left over. Seven, so 3 of them. Okay, y. So that's 2 full factors of y, so y to the 2nd is out, and there's a y inside. Okay, now outside, make sure you take 2 times 2, that's 4, and you're done. Okay, just remember, if you end up with 2 numbers out there, just multiply them. Okay. All right, now the game changes a little bit on the next page. See, right here, when you start the problem, you don't, I gotta get a Kleenex, sorry. I know it's just instantly stuffed up. Okay, sorry about that. Okay, now, when I see an addition sign, I can't really do anything unless these are the same, okay? They're not the same. So I make a table, and the goal is try to get them to be the same. So I got 6 radical 18 and 3 radical 50. And they both be 2's. They both be from the list of 2's, the big list. So 18's not here, so I divide into it, and I drop the 6, and I make 2 radicals out of that, okay? So 18 divided by 16 won't work. Divided by 9 does work, so I got 9 and 2. So that becomes 3, and I now have 6 times 3 times the square root of 2. Well, now I times that, that's 18 square root 2. Okay, now hopefully I'll end up with a square root over 2 here, because I have to have these be the same to do the adding operation. See, on the first side, there were only multiplication operators, okay? You're good there, but with the adding, they have to be the same under the radical. Okay, now 50. Again, 50's not here, so I drop my 3. Okay, 50 divides by 49, no. 50 divided by 25, yep. So 25, 2. So that becomes 5, okay. So I now have 3 times 5 times the square root of 2, and that'd be 15 with the square root of 2. Okay, so rewrite that. That became 18 square root of 2, and that became 15. square root of 2. Okay? So that's going to work right there. Okay, and then I look under the roots, and what do you know, they're the same. So I can now write just 1, condense it into 1, radical 2, and that allows me to add the outsides. 18 plus 15 is 33. Boom. Okay. Now this says FOIL, and if I was given a test, I would write that so you kind of had some direction where to go. You're foiling with radicals. So you got 3 and 5. Now 3 and 5 don't have radicals attached to them. So that's just 3 times 5. Then I go 3 to the negative 6. Now 3 doesn't have a radical connected, but the negative 6 certainly does. Radical 2. Then I go 4 to 5. Okay. The 4 has a radical 2 connected and 5. Okay. Then 4 to negative 6. Okay. So 4 has a radical 2 and negative 6 has a radical 2. Okay. Now I multiply. Remember I did this. 3 times 5 is 15. That's easy. Okay. 3 times negative 6 is negative 18. And then I just attach a square root of 2 behind it. Now, is 2 on this list? No, it's not, so I'm good to circle it. 4 times 5 is 20, and I put a radical 2. We already know that's not on the list, so I'm good to circle that. Now, 4 times negative 6 is negative 24, but I make a radical, and I got to multiply the numbers in the radical. I got to take 2 times 2, and that's 4. So there's a square root of 4 here. Yep, that equals 2. So I rewrite that as 24, negative 24 times 2. Negative 48. Okay, now, these two don't have radicals, so you can add those, okay? Those would go together. So I take 15 plus negative 48, and I got negative 33. Plus, then these two do have radicals and they're the same. So I put a radical 2, and when I put that down, I'm allowed to add anything outside of the radical 2. Negative 18 plus 20, and that's 2. Okay, and that's that. So that's all your simplifying you have to know. Now, solve the equation for x. Now remember, when you have to solve an equation involving a radical, okay, you want to kind of separate the radical from everything else and look at outside operations. We've got a plus 3 and a times 3. So we do the opposite of plus 3 first. That takes me to 12. Okay? I've still got 3 times radical x plus 4. Now I have a multiplying operator. So the opposite of multiply is to divide. So radical x plus 4, 12 divided by 3 is 4. Now we can get rid of the radical. You always get rid of that by taking both sides to the second power. Okay? So that now cancels. The radical's gone. I have x plus 4. Now over here I take 4 times 4. That's what 4 to the second means. It's 16. And I minus 4. And 16 minus 4 is 12. Okay, right here, you don't have a radical, so you just kind of think out the way. You have a 3 times x. We got to divide by 3. 81 divided by 3 is 27. Now, you have to get rid of a fraction power. Okay, you did an assignment like this. You probably need a refresher, and that's fine. When you are trying to get rid of a fraction power, you make a parentheses and you flip the fraction. Now to find what this is, first I need to use my radical sheet of 3 and see if 27 is there. Because that's what that 3 under the exponent means. It means the cubed root of 27. Well, that 27 is here, it's 3. And then we take 3 to the 4th, and that's going to give me my answer. Okay. So 3 to the 4th power. Okay, I got 81. Okay, next problem. Okay, you have a minus 3, so we got to add 3. Takes us to 5, and I've got radical 4x minus 23. Now we got it to get inside the radical, we have to get rid of the radicals. So we parenthesize each side, second, second. Okay, 4x minus 23. 5 times 5 is 25. Then we plus 23. That's 48, so 4x equals 48, and we divide by 4. 48 divided by 4 is 12, okay? Okay, final problem again. Now you have the fraction power, so do your plus 2. That takes you to 27. Now you have to reciprocate the fraction power, so that would be 2/3 and 2/3. So remember how this is handled, okay? First, get rid of that 3. Just look at the 27 with the 3. What that means is, what is the cubed root of 27? That's 3, okay? But it's now 3 to the 2nd, okay? So that's gone, that becomes a 3. Then it's 3 to the 2nd. And 3 times 3 is 9. Okay. I believe you have a graph paper stapled. I think these are the problems. Just let me get them written down. Y equals the square root of x, then minus 3 outside, and then y equals the square root of x plus 2 inside. If you remember how to graph a radical, first you make your parent table for square roots. Okay. So again, you want to start at 0, block off, because you can't put negatives in square roots. You have to do the I, which is not good when you graph, okay? So I look at my square root list, okay? So I would put 1, 4, and 9. And the square root of 9 is 3, square root of 4 is 2, square root of 1 is 1, and the square root of 0 is 0. Now we have to transform the function. That minus 3 is outside, so it's outside, so we transform the y. Outside, we don't do the opposite. We just do what it says, which is minus 3. So 3 minus 3 is 0. 2 minus 3 is negative 1. 1 minus 3 is negative 2, and 0 minus 3 is negative 3. So again, you want to plot that one first, okay? 0, negative 3. Because you cannot go past that point, this way anyway, okay? Because you can't put negatives in a square root. Okay, 1, negative 2. 4, negative 1. 9, 0. Okay, and there you are. Okay, that's your graph of that function. Now, the next one, again, it's square root 0, 1, 4, 9. So square root of 9 is 3, square root of 4 is 2, square root of 1 is 0. Now, we do have an extra value, a plus 2, but that's inside, okay? So now I go to the x, but when I do the inside, it's the opposite, inverse operation, okay? So if it's a plus 2, we're going to minus 2. So that's 7, 2, 1 minus 2 is negative 1, and negative 2. So negative 2 is 0. Negative 1, 1. 2, 2. And then 7, 3. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. Okay, that's kind of the things I want you to know at this point in time through this unit, okay? Hopefully it made sense. I might give you a practice packet tomorrow.